Ladies and gentlemen, please welcome Stefano for his presentation from zero to hero.
The audio? It's okay, the audio? Yes, now I think so. So thank you, everyone. Welcome to this session about AI. Before starting, let me launch this.
Hello from AI and welcome to BC TechDays 2025. I am Kokoro, an open-weight text-to-speech model with 82 million parameters. I am here with my friend Stefano to show you what you can do with AI today. Yes, I am running offline on Apple MLX. If you think I am cool, this is just the beginning. In this session, Stefano will talk about Semantic Kernel, a lightweight open-source development kit from Microsoft that lets you easily build AI agents and integrate the latest AI models into your solutions. Semantic Kernel is cool, yes, but probably I'm better. Grab some water or something stronger and prepare for a session where we'll see little owl code and a lot of net code instead. It'll be tough, but if you survive, you'll be ready to create serious AI solutions, not little games like those made by my friend Copilot Studio. Now I have to stop entertaining you, or the guy next to me will get angry. Enjoy the session. I'll wait for you at the bar. See you with me and Stefano in a next AI event near you. Oh, only if Stefano will not decide to go biking instead. Ciao.
Okay. There's also an animation that, sorry for that, was not able to display. So this session is about AI, as you can imagine. And especially the goal for this session is giving you all the building blocks that you need to create in order to create AI solutions that overcome the limits that you have in low-code application like Copilot Studio or something like that. So the goals are giving you the building blocks to create AI platform independent solution, so a solution that can work with Azure, OpenAI, Google, and something like that. That works with Business Central, obviously. We are in a Business Central conference, so this is obviously the goal. Supporting agentic AI. This is another goal of the session, so we will see how we can support agentic AI with this framework. Supporting also private AI, so not only forced to be able to work with AI solution that runs online, but also with AI solution that can run on your own machines or your on-premise network. Also, obviously, cost is important, so also AI solution that has the lowest cost as possible. So not forced to be pay for Copilot Studio packages of messages and something like that. So something that is totally independent from your AI vendor. For that, before starting, usually when I propose AI solution to customers, this is always a fight because customers, lots of AI projects fails usually. This is a statistic from Gartner, but I think that is true. At least in my experience, when proposing AI is not easy with customers, especially because, first of all, customers often missing AI readiness, so they are not ready too much for AI, and they have some misconceptions about AI. So, for example, they think that AI is limited only to some applications. The AI cost seems high, so how can I predict my AI cost? This is something that where customers are worried. AI implementation usually is something complex, at least is seen as something complex. And the AI value that you have when you invest money in AI solutions sometimes is obscure to the customer, so is something that I can invest or not. So these are all a set of misconceptions the customer has. And usually I see that what customers want is, first of all, obviously, an AI solution that provides real value to their business, not a generic AI solution. Second, they want to control the AI cost. So I want a solution that I will not be, where I can have predictable cost, not unpredictable cost. I want also that an AI solution that can be totally disconnected from the AI platform. Why? Because I think that you follow AI, AI is changing every day. Every day, new models, always more powerful are out. And why I should be forced to create an AI solution for a corporate that is using, I don't know, Azure OpenAI models when, for example, there's a model that is much better for me in terms of cost, in terms of performance and so on, from another provider. And then an AI solution is like any other solution, should be scalable, not simply calling a prompt, because one user that calls a prompt is different than 1,000 users that calls a prompt. And autonomous also. We want that an AI solution should be autonomous, so decision for me, work for me. So for these goals that I see, at least are the goals that I see the customer wants, in the AI world, generic AI world, a set of AI frameworks are born from different vendors. So the most famous, I listed here the most famous, but there are also other less famous probably. Today we will talk about one of the Microsoft AI framework solution. So that is called Semantic Kernel. Before starting, I want to, before starting specifically talking about Semantic Kernel, I want to start very quickly introducing some concepts of AI concepts that probably for you are well known, but I prefer to introduce. First of all, I think that you know that an AI, when you send a prompt to an AI model, the AI model starts parsing that prompt. It creates a token probability for each content of this prompt, and then according to the probability, it gives you the answer. This is how usually an LLM works. And LLMs also supports conversations. So this means that you can start passing first prompt, the LLM gives you a prompt, and then you can start, like in a chat, send another request to the prompt, and sometimes the LLM responds that he has no knowledge of the previous of the question. If you send to the LLM a question related to the previous answer, simply because an LLM is something that out of the box has no memory. So an LLM should be enriched in order to support complex conversation. How should be enriched? With tools and memory. Tools is probably the most powerful toolbox in the AI world when we talk about enterprise AI, so corporate AI. And then there's memory. Tools are things that you can provide to your LLM in order to work with your application, with your data and so on, and then there's the memory. The memory is something that an LLM is using to work with your data. And LLMs today are also able to reason. Reason means that when you send a prompt to an LLM starts analyzing that prompt and starts performing a set of operations, reason steps, before giving you the answer. And you can check these steps or not. It depends by you if you want or not to see the reasons. We talk about the memory. The memory is absolutely important when talking about LLMs. LLMs has short-term memory and can have long-term memory. Short-term memory means that I send you a question, you give me an answer, I can then send you another question, and probably if I don't do nothing, the other question, if it's connected to the first, the context is forgotten. But you can handle that, and you can have a multi-conversation until, obviously, you reach the maximum capacity of the context window of this LLM. Then you can have also long-term memory. Long-term memory means that an LLM can also analyze data, complex data, and working with that complex data, maintaining that complex data context. Usually, long-term memory is handled via vector databases. So you have a conversation and an embedding model. The conversation is sent to the embedding models, converted to vectors, and saved into a vector database. The vector databases are mandatory if you want to work with a large set of data. Otherwise, the LLM cannot contain in memory, in this context window, all your data, for example, coming from your ERP. When you handle what is called a long-term memory, so a vector database, your prompt is sent to an embedding model, converted into vectors, save it into vector database, and then when the conversation is started, the LLM checks for the vectors what is the vector that is more probably used to be answered to be able to answer my question, and then start reasoning and gives you the answer. This is how the memory works, and we'll see how we can handle that in using this framework. Last concept, probably absolutely well known because it was spent a lot of time talking about that in this conference, is about agents. What is an agent? Simply is, in short word, is an LLM-powered system creating for autonomy to take action and solve complex tasks. So an agent is an entity that is can have tools, can have memory, and can plans for solving a particular task. When talking about agent, in the Microsoft world, there are a set of possibility to create agents, and also in the keynotes this morning, some of that was explained. So we have no-code solution, so fully no-code solution, which spans from fully no-code solution to fully pro-code solutions. Starting from no-code solution, first of all, you have out-of-the-box AI features. Out-of-the-box AI feature means features that you have inside Business Central and you can use as is, like the Copilot chat or some of the tools that you see this morning in the keynote. So these are tools that you can use and you cannot modify. Then in Business Central, you have also the IL SDK for Copilot that permits you to create IL solutions, your custom solution, but obviously are fully linked to what Microsoft is exposing to you. The second step, if you want to a bit more, is Copilot Studio. Copilot Studio is a low-code agents system where you can create agents. It's limited on models. You cannot select every model you want, but only the models that are exposed by the platform. And also, one of the limits, obviously, is the pricing. Copilot Studio has a pricing that is absolutely different than the pricing of an LLM that you can use for in every LLM provider. And it is tightly coupled to the LLMs that Microsoft opens. Then there are the pro-code solution. The pro-code solution, what was not explained this morning in the keynote, but today is where we have the focus. Pro-code solution is a solution that you can develop as a developer, so totally independent from the platform, from the vendor. This obviously means that you need to have full code, so writing in something that is different from a language. In this case, you have no limits everywhere. You can create full code agent support. You have scalability. You can use any AI model, any AI provider. No limits on that. They can also run everywhere, as I previously told. Obviously, they require pro-code skills. So the focus, this is the Microsoft ecosystem. The focus today it will be in that part. So this is usually a standard Microsoft slide that Microsoft presents when talking about its AI platform. We will focus our attention on Semantic Kernel. So the framework that Microsoft is using internally also to create all of their AI platform, their AI tools. Why we are talking about that? Because Copilot Studio, that is great. So disclaimer is great. No, but in my opinion, it has a lot of limitations. At least for creating any AI solution. First of all, it has a rigid set of predefined functionalities. You cannot do what you want, but only what is available inside Copilot Studio. It's a low-code tool, so good, because it don't require coding skill, but it's less flexible if you want to create something that is not possible from the low-code platform. It supports agent creation, recently introduced in Copilot Studio, but its primary focus on single agent, unless 2 days ago or 3 days ago, the multi-agent support is added in preview also in Copilot Studio. But it's not like a full code solution. And you have also other set of limitations that I don't want to list. First of all, the scalability and pricing. Copilot Studio has this. Copilot Studio also recently added the support for plugins, custom plugins, and one of the custom plugins are Semantic Kernel plugins. So all what you will see starting from now to the end of the session can also be used in Copilot Studio, and this can be useful in order to extend Copilot Studio. So if you are a pro developer, they can create custom AI solution that you can recall, custom agents that you can call, for example, from a low-code solution in Copilot Studio. So let's start by talking about semantic kernel. That is the focus of the session. What is semantic kernel? First of all, semantic kernel is, in short definition, is an open source development kit provided by Microsoft to create complex AI solutions with some goals. First of all, it must abstract AI models and providers. So it must be able to run with different AI providers, not only Azure OpenAI. Second, must be flexible. Flexible means scalable, means adaptable to different scenarios. Must be modular. You add to the kernel, the main part of this framework, all the system, the services that you want. So able to add modules. Needs to support agents, multi-agent solution, and needs to support memory, because it's one of the mandatory features in order to work with large volume of data. Here, in the slide, I've also mentioned a recently definition that Microsoft has given at the recent build. So semantic kernel is at the core of all its their AI agents and platform that they provide. Obviously under the hood, but we are talking under the hood today. So probably difficulties for traditional IL developers. Obviously, semantic kernel is not embedded in IL. There's nothing, so you need to write required coding skills different than the IL language. But you can, when you have created that, you can use from IL language, and we'll see that in the session. So why semantic kernel in Business Central projects? Because when you propose AI solution to customers, not all needs can be satisfied with the standard out-of-the-box feature, so from IL language, very limited, or not all these features can be, requests can be satisfied by Copilot Studio, absolutely. So sometimes you need a solution that can scale, that can move between models and so on, and semantic kernel provides a lot of these. Sometimes you need, for example, one of the common requests is to support Retrieval-Augmented generation, RAG, and if you want a solution that don't cost you hundreds of euros, sometimes is better to use these tools. Semantic kernel is a framework composed by 4 main components. The first is the kernel. The kernel is what coordinates all the AI tasks that you define, and is something that the main building block of this framework. Then there are the AI services. The AI services are features that the kernel has in order to support different AI services. And semantic user wraps for you, semantic kernel wraps for you this interface between different vendors, between different providers. So your solution can work with Azure OpenAI, can work with OpenAI, can work with Google Gemini, and something like that. Semantic kernel also supports plugins. So plugins are the 3rd main components. You can define plugins. Plugins are functions that you can add to your AI solution in order to do complex tasks or work with your application, with your data, and something like that. And then semantic kernel supports agents. So it has components that permits you to support different agentic patterns in order to support also multi-agent solutions. So semantic kernel, first of all, what languages? At the moment, it supports these languages. So C#, Python, and Java are needed in order to create semantic kernel components. Today I will use C# for the other stuff, so the demo part. Microsoft provides all what you need in these packages. Microsoft.semantic kernel available for every of the supported language. This is the package that contains everything you need to start in order to create this type of solution. This package is as a standard core capabilities, so standard capabilities available for everyone. Java is only missing logging, OpenTelemetry log support, otherwise it's totally supported. And also as as you can see from the right side of the slide, supports different AI connectors, so different vendor connectors. Online connectors like Microsoft, like Google, like Amazon, and also offline connectors. So you can also, your solution that you deploy for the online world can also work offline. And this is something absolutely interesting in my opinion. So first of all, let's start with a very quick demo of the basics. The basic, when you create an AI solution, the basic is the chat completion. Chat completion means I have a model online deployed. I use for the demo a model deployed in Azure AI Foundry. So I don't show this for timing, but you go, I think you know that you can go in the Azure portal, go into Azure AI Foundry, deploy, for example, GPT for one model, and then you can start working. So I will use that, but I will show you that the solution created for Copilot for Azure OpenAI can also work with, for example, Google Gemini or other, or Amazon Bedrock, that is the AI model provided by Amazon. So let's start with the chat completion. For that, I will switch to this project, okay? And I think I need to also enlarge. Can you see? Okay. So first of all, how we can use semantic kernel from, in this case, .NET. Chat completion can be handled with three simple set of lines. The first, well, first of all, you need to reference Microsoft.semantic kernel. This is needed. It's the package that contains everything. Then you can create the kernel, and the kernel can be simply created with this line of code. So you reference the package and you call the create builder method. The create builder method is the method that creates the kernel, so the service. But the kernel without, only with this line, can do nothing. It's like a service without nothing defined. Then you need to, semantic kernel, as you remember in the previous slide, you need to add services to semantic kernel. And to add services, you need to call the create builder returns an object called builder. And then you need to add the services. And semantic kernel supports different services. We will see later. The first of all that I want to explain is the chat completion. A chat completion can be different according, it supports the wrapper to the chat completion for different vendors. So here I'm using Azure OpenAI chat completion because I want to talk with Azure OpenAI models. But later I will show you that, for example, with simply changing this, I can support Google. Then you need to build the kernel. This is the service that starts and runs the service. And now, after the build, you have the service ready. And then you can, here I've simple create a while loop. If I run this, I run this. Here there's a simple, let me open. I use the console now just to show you the components. So here I have a question. I can type a question. For example, I don't know, where is Antwerp? And the question is sent to the LLM, and the LLM is responding me that Antwerp is a city in Belgium located in blah, 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 blah. So it's a very simple question. But what happens now? If I respond something like, and Milan, it returns me, could you please provide more context? Because I don't know. And Milan, what happens, what means to me? This is the first problem of LLM, short memory. So LLMs, I send the question, it don't have the memory. It cannot reference that question. So if you want to support memory, you need to do in your component something different. And something different what is, let me close this. I comment this for a moment. And I start the other part of the demo. that is this. It's absolutely the same as before. I will explain. But in this case, this is a comment. In this case, absolutely the same as before. But in this case, I'm supporting the possibility to add the context to the chat. So it starts a chat session, but I maintain the context to the chat session. So every request that I send to the LLM is saved into a session called chat. In this case, a chat completion session, and it maintains that context. In this case, if I run this, and I need to rebuild this. Okay, and now run. What happens now is that if I do the same thing, so the user, where is Antwerp? It should be, okay, Antwerp is, and now if I, and Milan is a city, blah, 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 because he has the context. So the session has the context of the previous, and is, if you want to have a service that is able to maintain the context with the user, you need to support that. Otherwise, you lose the context. And as said before, Semantic Kernel is absolutely permits you to create an AI solution that is totally independent from the model. So here is, for example, the same supporting Google. So if one day I decide that, okay, now Google has released a model that for me is best, I can simply change this from the previous I add Azure OpenAI chat completion. Now I add Google AI Gemini chat completion. Passing, Google wants the model ID and the API key. And now I support Google. My solution can switch between different models. The rest of the part is totally different. So this is one of the powerful things of Semantic Kernel. You can switch between models. You can also have, when we'll talk about agents, we'll see you can also agents that respond connected to different models. And this is one of the greatest things of Semantic Kernel. Let's do a step more. Here is the basics. The basic is the chat completion. A step more is the memory. In one of the common requests of when providing an AI solution to customer is I want to chat with my documents, I want to chat with my data, and something like that. For that you can imagine that you want to chat with the content of a document. You cannot pass the content of an entire document to an AI model and say, okay, can you answer this question? Because the context of an AI document can be much, much bigger than the context window of the model. So you need to support what is called Retrieval-Augmented generation. So a technique that permits you to something like transform your AI model to a search engine. So it is able to parse a document, convert this document into vectors, and chat with these vectors. And so for that, when you want to have a complex AI solution, for example, that is able to work with your corporate data, imagine your corporate documents, you need a vector database, an vector index. So first of all, a model that supports embedding, and split your data into vectors. Semantic Kernel wraps that for you. So first of all, supports different type of vector databases. And then wraps for you all these complex stuffs by introducing what is called the kernel memory. The kernel memory is a service that abstracts all these concepts. For you, it's just simple. You specify what type of memory service you want, and then Semantic Kernel wraps that for you. And this is absolutely powerful for many reasons. First of all, because you don't need to call an embedding model, then call, for example, Azure AI Search and something like that. So you don't need to have in place all these different calls. And second, because it permits you to support, without doing quite nothing, different vector databases. Azure AI Search is absolutely powerful, but sometimes can also be costly. There are different vector databases that are absolutely less costly. One of these is, for example, Azure SQL or SQL Server, that from the last releases supports vectors. And if you have an AI solution that needs to work with 1 terabyte of documents in your corporate, it's much better to save, much better in terms of money. Save vectors into Azure SQL that cost you quite nothing, instead of using Azure AI Search that can cost to you probably some thousand of money. This is a scenario that can be useful. Semantic kernel memory, how works? Works simply, you pass unstructured data, documents, JSON files, XML files, something like that. They extract the content, transform the contents, save the content into this vector storage. And then you can, from your AI model, you can type a question, something like that, and you can interact with these documents. To show you a very quick demo how to use the memory, this is the example. Let me zoom a bit. Using the memory is very easy. So absolutely, probably much more easy than other system. And with few lines of code, you can fully support Retrieval-Augmented generation of your documents, and then call this, from example, from Business Central, and provide the solution to customer. Personally, I use this solution in many projects, or for example, for chatting with the attachments connected to documents inside Business Central. You can do that very easy. First of all, you need to declare, you need to reference a package for supporting memory called Microsoft Kernel Memory. This is a service that permits you to support the RAG techniques for Semantic Kernel. And then you declare your object kernel memory. It's like Semantic Kernel was builder. Here is kernel memory builder, the object for the memory. And the memory needs to have an embedding model. So here you need to have deployed in your this case, in my case, I use Azure OpenAI. So in my Azure OpenAI, I have an embedding model, text ADA 003, for example, and I have an LLM GPT-4.1. So here I'm passing what is my embedding model. So my details of the connection of the embedding model. And here I'm passing the details of the connection of my GPT model. So my model that needs to interact with this data. And here is the part, there are other configurations, totally optional, for example, maximum number of tokens for response, something like that, so I omit that. But here is the part that I want to focus. So, what memory? Previously, I defined that for the memory, I need a vector, an embedding model, parameters, LLM, parameters, and then what memory I need to use for storing my vectors. And here, I can select different. For the demo, I use what is called the simple file storage. Simple file storage means file system. You can, if you have a small solution, and you want to pay for nothing, you can save the embedding into a file system. Your document will be parsed into a file system. You have a folder with a set of unbelievable for you data, but these are the embeddings that the LLM can use. But obviously in a production environment, you will never use that. So I've left the comments. For example, you can use SQL Server memory. SQL Server means you can pass a connection string of an Azure SQL, and all the vectors are saved of the documents that you pass, or the data that you pass are saved into SQL Server in a fully transparent way for you. You don't do nothing. Or you can use other providers. Azure AI Search is the Microsoft provider, so Azure AI Search. If you want to use Azure AI Search, use this, passing the connection string of Azure AI Search, and you can work with Azure AI Search. SQL Server is what I suggest for many projects today, costs quite nothing. But you can also use third-party. Concurrent, for example, is a vector database, absolutely powerful, that you can use. If you know Central Queue from my friend Dimitri, Central Queue uses Concurrent for storing documents and vectors. It's totally up to you. So you can decide what is the vector service that is better for you. For the demo, I'm using what is the poor solution, so the file system. Simply doing that, what I'm doing that, I'm creating, as in the previous demo, a chart completion service, and then I'm saving the documents. So here I've done all in a single file in this case. So what is doing here? I'm passing the path of a document that I want to give to the LLM, so to store into my vector database. In this case, is the Business Central licensing guide. And with one single line, I can pass that to the kernel memory. The kernel memory do the work. So parse the document, save the vector, and the vector is saved into the storage that I've decided. In my case, is the file system. Then I can start the chat. So if I run this, let me build, because I don't remember if I changed something, so I prefer to rebuild. So if I rebuild the app and I run the app, what happens here? The code starts and it parses the document. Obviously, you can load the document when you want. And then it starts asking me my prompt. And then here I can ask something like, I don't know, explain probably the most tricky question for a Business Central related agent is explain the team member license, because also Microsoft doesn't know the response to that. So team member license for Business Central, and here the LLM is not going to internet, because it automatically is able to discover that for the answer of this question, I have an embedding database, and I can retrieve data. And as you can see here, is giving me the response. So blah 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 blah. It's explained all the data about the Business Central team member license, and it's also giving the reference. So the reference is not coming from internet in this case, but it's coming from the document that I passed to the memory. So imagine in a real world scenario, you can pass every document you have attached in Business Central, and then you can have inside Business Central the possibility to chat with that document easily without doing quite nothing. This is what is called Retrieval-Augmented generation, so support for RAG. Very, very easy. So you don't have to do quite nothing. 3 lines of code, and you can fully support RAG with this tool. So I close this, and let's do another step in explaining more complex features. Previously, we talked about 2 powerful features that an agent can have. Memory, and we saw the memory, and functions, plugins. Functions or plugins, Semantic Kernel uses this terminology, plugins. Plugins is a group of functions that they can be exposed by an AI service, and these functions can be used from the AI service to interact with the external system, with your database, with the different applications, and so on, automatically, without doing nothing. So you provide a set of tools to your AI agent, and the AI agent is able to automatically use this tool or not, according to the question that or the task that he needs to support. So Semantic Kernel supports two types of plugins. What is called prompt templates. Prompt templates are the most simple way. You can define templates in plain text, and it is able to use and create automatically a plugin from the text. Or native function. Native function means something that you can define in code. Plugin, we will see a demo about that, but a plugin with native functions can be, the first is text, and we will see how to do that. The second is plugin with function. With function means that you need to create a function in code, and this function must be decored with the kernel attribute, the kernel function attribute. Semantic Kernel is able to discover, when you send a request to the LLM, what function need to invoke in order to satisfy the particular task, if you declare that the function as kernel function. A kernel function can have parameters or not, it depends by you. It is absolutely important to, as in the slide, to add the description of parameters and the function, because an AI model, not so in general, an AI model, when calling a function, uses the description in order to know what is the function that I need to call for satisfying this task. So you need to declare the function. Second step, you need to add the function to the kernel instance, and this can be done with this the first line, red line of code. And the third, you need to say to the kernel that it can auto-invoke the function. So when you, AI model, want to satisfy a task, decide the autonomy to invoke the function that you need to perform the task. So this is the standard way. And another very powerful, recently introduced way to enrich semantic kernel with function is using logic apps. Logic apps is, I usually call it the father of Power Automate. Is a more pro Power Automate. And it's a low-code tool that permits you to create workflows. And semantic logic apps has, first of all, a feature that can be exposed, the definition of the workflows as Swagger. Swagger is a JSON format. And semantic kernel is able to automatically discover, if you have logic apps workflows, it's automatically able to discover that and automatically invoke these workflows if user prompts a question and it discovers that with this workflow I can answer this question. And this is I have a demo for that. This is a nice mix because in this case you don't need to define functions in code, but you can have a local developer that can create different workflows, and you as a developer simply with this line you say to the kernel, okay, dear kernel, go into this URL, that is the Swagger definition of the logic app, and then discover all the workflows and do what you want. And I will show you how it works in a few minutes. So, first of all, the basic of the function, that if I don't remember is this project. Let me go because I know it's not this project. I think I not opened the project. The first is this. So function, three ways to define functions. The first is using what is called prompt template. Prompt template is simply a function defined in this way. So it's a TXT file defined in this way. So message role user, and then you can write the prompt. Here is a stupid function that I created. So tell me an interesting fact from Word about an event that took place on. This is the way to pass parameter. This is a parameter. Be sure to mention the date, blah, blah, blah. Then I have a JSON file that is, this is totally documented online. This is a way to create prompt templates. This file says that this function defined in TXT, this is the description of the function. This is some settings that you can have, for example, maximum number of tokens or something like that. And this is the parameters that the LLM need to pass. So a parameter called today that contains the current date. What happens here is that if I run this, the application starts, discover that today is June 12, and this is the effect that occurs in June 12 in 1987, US President Ronald Reagan delivered blah, 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 blah. So this is a prompt template, so a function defined in a TXT file. This is a possibility. I never use this possibility, honestly. The most powerful way to define a function is what I will show you in this other example. So is by defining the function from code. And defining the function from code means exactly what I explained in the slide. So I can declare a function. A function is simply a procedure decorated with these attributes, with parameters or not. Important, as I said before, specify the description, also if you have parameters. So in this case, my function is get current day that returns the current date because I want to retrieve the system current date to pass to the question. And then semantic kernel, simply when I declare my application, I can simply add this line. So here, as we saw in the previous demo, I create the kernel. I add the chat completion service because I want to interact with my model. And then I enrich my kernel with functions. And semantic kernel supports these plugins.add from type. And this means that it goes in this class, it retrieves all the kernel function and adds that to the context of the AI service. And then I can start typing. Here is my prompt, exactly like in the previous example, tell me an interesting fact, blah, 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 blah. And in this case, if I run, sorry, my mouse is crazy. But why not? Okay. If I run this, I should have at least the same, not this, but this. It's not easy to type with the light. Okay, I should have the same answer. But in this case, the function is native. So native means defined in code. The third option that I previously explained is a bit more complex option. And I will explain this complex option in this. Here is my Azure portal. And in my Azure portal, I have a different set of workflows created by using Azure Logic Apps. So I have, and this workflow uses, I don't know, for example, open one. These workflows are using Logic Apps and the Business Central connector and every other connector I want. So in this case, It's a workflow that works on we use the Business Central connector for searching for production orders and giving a response. If you want to define the workflows for an AI model callable from automatically callable from an AI model in low code, in this case using logic apps, your workflow needs to start with an HTTP, empty, but this is mandatory to have the HTTP connector when a request is received as a startup for the workflows. And logic apps have an option, configuration option, that permits you to expose a Swagger, so a JSON definition, that is this. You cannot see probably, but it's a big JSON that contains all the definition of the function that I have, because as you can see here I have different workflows. For each workflows, my low-code developers has created the workflows for with the Business Central connector for doing a set of stuffs, retrieving production orders, changing inventory, and something like that. And here, the JSON exposes the workflows and the endpoint to call these workflows. What I have done here, if I remember, okay. Here is a very basic demo that I don't know where is. Sorry, 1 second. Okay, this demo. Here I use a web application, but the focus is not to the application. The focus is what I need to do in order to do that. Here I'm asking something like list production bombs containing the item, a particular item, because I want to use an LLM in my production department. My production department wants to have a capability to interact with the production order. And for example, one of the features is I want to know if an item is present in some production bombs, because maybe I want to change the item or something like that. And I can send a request. And wonderful. Let me. I think he has lost the connection. Let me try to reopen, because I previously opened the project, but they're switching networks. So I'm logging. So what I want to show is that I'm typing a question in this interface, and the interface automatically is able to discover from my set of workflows what workflows need to be called in order to satisfy the question, is able to call the workflows and give me the response. And I can have then the logs of the requests coming from the workflow. So list, don't remember the item name, production bomb containing the item. Item is SP bomb. If I don't have problem in connection, okay, now it's answering. So it's able to call my workflows. My workflow goes in Business Central, searching for the data, and then it's able to retrieve me the data. How to do that is absolutely very easy, because you don't need to do quite nothing. Simply, from your workflows, you need to, I want to enlarge the resolution. You need to go here and add this line. This line is called, from your kernel instance, import plugin from OpenAI API async. And this means that the kernel is able to inherit all the workflows coming from this OpenAI definition and automatically call them. So if I go in my Azure portal, I don't remember where I have the Azure portal opened, here. If I go into my Azure portal, if I check my workflows. Probably this. I don't, okay, this is the workflow that was called. So the AI model automatically has called the workflows according to the question. So it's able to automatically discover and call the workflow. And this is useful because a local developer can define that. Let's jump. So here is how functions works. Now let's put all this together and let's start talking about agents. Semantic Kernel supports agents. Agents obviously are entities that can work autonomously to complete tasks. Semantic Kernel has recently introduced what is called the agent framework, so a platform to define patterns for supporting multiple agents working together and something like that, without doing too much complex operations. And the agent framework is important because you can create autonomous agents, you can create agents that works and takes decision accordingly to a set of collaboration patterns, and can interact also with the human in the loop. And Semantic Kernel supports, at the moment at least, this type of agents. So Azure AI agent, so agent defined in Azure AI Foundry, supports chat completion agent, so agent defined in code by you that can interact with the model. Supports OpenAI assistant agents, so agent created in OpenAI using the assistant API. Supports Copilot Studio agents, so if you have an agent deployed in Copilot Studio or created by someone else in Copilot Studio, you can use that also in Semantic Kernel applications, and they can call different agents. And also support Bedrock agents. Bedrock agents are agents in the Amazon platform. These are actually the agent the agent platform supported. And also it supports agent patterns. Agent patterns are orchestrations of agents. Different pattern orchestration of agents. And it supports the following pattern. The first is the sequential orchestration. Sequential orchestration means that I can define different agents, and then start the first agent, then the first agent does some things, pass the output to the second agent the same, and then the third, and so on, is sequential. And then at the end, I have the response. Second step is supports the concurrent orchestration. Concurrent orchestration means I have an input. This input is shared across all my agents. All my agents works on that according to the task that an agent is need to do. And then the output of that is put together, and then I have the response. This is the concurrent orchestration. The third pattern is what is called the group chat orchestration. Group chat orchestration is a collaborative conversation between agents plus the human. Sometimes Semantic Kernel can detect that for the particular question I need to ask to the user something more. So you can also take the human in the loop for that. And then, so a set of collaborative operation between the main service and the value you have, and then you can have the response at the end. And the last pattern that it supports is what is called the end-off orchestration. The end-off orchestration means that you give a task to your agent. There's a main agent that is intercept this task, and it redirects this task to the other agents according to the type of task that you have specified. Like, for example, if I have an order entry or a refund service, one agent need to create orders, and the other need to create refunds. If I have a request about creating a new order, the request is sent to the order agent, not to the other. So this is what is called the end-off orchestration. So let's see that. How to support multiple agents in Semantic Kernel. Semantic Kernel supports multiple agents in this is an example. supports multiple agent patterns. Let me reduce the resolution. Okay. When using multiple agents, you need, well, as usual, you need to define the kernel, same as before. So in this case, I'm using Azure OpenAI chat completion, passing my parameters. Then I need to define the various agents that I have. And in a most simple way, an agent is what is called this object, so chat completion agent, name of the agent, some parameters, so the agent has a name, must have a description. These are useful for the kernel in order to discover what is the agent need to do. Need to have the instruction. The instruction is the prompt that an agent need to have. Obviously, in this simple example, I place that into the code. Recommendation is, if you have complex solution, don't place the prompt into the code, but take the prompt from outside, because you can turn up accordingly without changing your code. And then the agent needs to have, what is the kernel instance? This. Why the kernel instance attached to an agent? Because in a complex AI solution, I can have, like in this example, 3 agents. One agent works with Azure OpenAI GPT for one agent works with Google Gemini. One agent works with, I don't know, GPT-4o, or something like that. In this case, I have different agents, the analyst, the copywriter, the editor. One or each of them has a task. So these are my agents. The analyst needs to extract key concepts from a product description. The second is to write a marketing description from what the first extracts. And the last, the editor, needs to correct the grammar, check the grammar, and give me a business description of my item. Here I'm using the first pattern, so the sequential pattern. So after defining the agent, you need to start an orchestration. The orchestration is how I need to orchestrate the partner, the various agents. In this case, it's sequential. Sequential means that first need to work this agent, second needs to work this agent, third needs to work this agent. So it's sequential. And in this case, I start the runtime of the agents. So my agents are up and running. And then here I started the prompt. So my prompt is a description of an item. And then, like this stupid example, is an eco-friendly stainless steel bottle that keeps drink for 24 hours. And then my agent need to work in order to create a more complex text. So here I'm running my application. And what happens here is that I have my input, and my agents, after a bit of time, works together and gives me this text that is the output. So first, he has taken the description. The second is create a more marketing description. The third is check the grammar. This is the output. So my agents start in sequence. There are different other types of agents. I don't very quickly. Concurrent is the same. Here I have an example of concurrent where I have a company info agent and a company stock market agent, because my goal was I ask you information about Microsoft, for example, and the first agent, in parallel, these two agents need to work. The first needs to check for retrieving information about the company, and the other retrieving stock market, because maybe I want to invest in Microsoft, I don't know. And in this case, I start a concurrent orchestration. Concurrent means that I need to pass the name of my two agents, and these two agents will be started concurrently. So here I'm asking, give information about Microsoft, and my two agents will start concurrently. So if I quickly do this and do this, let me rebuild everything. Okay. So in this case, my agent will start concurrently. They start thinking. And after thinking, one needs to retrieve information about Microsoft as company, and the other needs to retrieve information about Microsoft as marketing value. At the end, I have an analysis. So my here is I have analyzed mix both. So as you can see, I don't know where it starts. First, I have the analysis about Microsoft as company, and then I have also the values of Microsoft as in terms of marketing, so the Nasdaq value and something like that. So two agents have worked in parallel in this case. The last and probably more complex scenarios is the end-off. The end-off means that I need a task to an agent. I have different agents, like in this case. In this case, I have created different agents. The sales office agent that is able to, if you remember the chart, there's an agent that retrieves the request. And in my case, is this agent. So sales office agent that handles customer sales requests. Then I have two other agents. The item availability agents, that is an agent that is able to, responsible for checking the availability of items in Business Central. Then I have an order creation agent, so handle the creation of sales order for the requested items if there are available items in Business Central. And then there's a totally different agent, so the order refund, that needs to handle refunding of orders, so not linked to the others. Then here I'm starting the end-off. The end-off means that there's a main agent, this sales office, that according to the task can decide what is the agent that needs to solve this task. And the end-off, when you define this pattern, you need to specify what is the agent starts first. So the sales office agent is who receives the request. Then what happens? He can redirect the work to these three agents: item availability, order creation, and refund. And then you can also have other movements. So if the item availability agent receives a request that is not pertaining to him, he can transfer the request to the sales office again. The same for the order creation. If the answer is not for him, redirect to the main. So the main is act as an orchestrator. Then you start the orchestration. The orchestration can also have the human in the loop. So if you want support human in the loop, so also permitted that the agent can ask the user more questions, you need to simply add this pattern, iteration callback equals a function, this function. And in this function, you need to support, you need to have this signature. This signature means that the agent can redirect to this function if something requires a human intervention. And here I simply asking the input for the user. If I run this, I need to uncomment something. So not this demo, but now let's move to this. Let's start this. Okay. No. Okay. Okay. I'm asking, here my agent is listening. So I can type something. And the first agent that intercepts the user question is my first agent, what I call the sales demand agent. So I'm asking something like, I need to order 16 because I've in my code, I've not showed that before starting the agent. In my code, this code. I've also, obviously, when you have an agent, so this agent, 1 second, sorry. When I declare an agent, you can also enrich the agent with functions. And where is my agent? Okay, this agent. These are all my agents. All my agents can have a function. For example, the item availability agent, to check if an item is available in Business Central, need to do something. And here I've created a function called item availability plugin that contains the possibility to go in Business Central and checking for the availability for an item. And this agent has this tool available for performing this task. The same for the other. These tools simply are functions like this. So it's a function like previously shown, kernel function, my function, with here should be the call to Business Central for this particular item to check for the availability. Now I'm returning 10 as fixed because just for a demo purposes. If I go into my, I need to order 16 item 01. The agent, as you can see from the response, the first agent, sales agent, intercept the response, redirect the response to the item availability agent. The item availability agent has checked for the availability, is returning 10. I want to order 16. Is asking, okay, should I proceed to create an order for the available quantity or not? So it's asking for interaction. And I can, yes, order 6 item 01. I don't know if the sales order is created successfully, blah, blah, blah. So it's able to redirect the request to the right agent, perform the user interaction if it needs something, like in this case, I don't have enough quantity in my warehouse to satisfy the request. What should I do? So you can have the human in the loop. Obviously, so this is the agent orchestration. You can define multiple agents and have multiple agents running and working. All this demo at the moment I've done using a console application because it's much quicker to do that. But you can do everything also from Business Central. So here is another example, a real example that I have in, for example, in Business Central. So in Business Central, you can call AI function in 2 ways. The first is standard Azure OpenAI, standard way IL SDK for calling Azure OpenAI. And the second is, like in my case, in this demo, I don't use standard Azure OpenAI features, so I don't have these settings. But instead, I'm calling my service running in an Azure function, and my service is a semantic kernel agent that is able to receive my questions and working with my Business Central data, like with the toolbox that I previously displayed in the demo. What happens here is, here I can ask to my data not only basic question like in the Copilot chat. I think that you have used the Copilot chat, the standard Business Central, you can ask some questions, but if you can if you start asking for more complex questions, it fails because it's giving answer that is not able to answer to some questions, something like that. Here I can, in this example, for example, I can do something more. I don't know, something like show the sales distribution. Sorry if I don't able to write, but it's not easy to see the keyboard by region. Probably the first call will be slow because I have a service now deployed in a very low tier. The other call will be quicker, but the first is the call start of the function. And what I want to show is that in this case, let me redo because come on. It's the function under the hood that it was sleeping because the Azure function goes in, okay, now it's working. The agent here is able to perform a more complex data operation in my data. So I ask not a simple question, but here you need to perform an analysis of all my sales and giving me the response. So it's much more complex, and it has given me the response. So this is the amount of the sales that I have in my Business Central data grouped by region. But I can also do something like, I don't know, something like, for example, analyze the inventory levels, analyze how the inventory level, maybe how the inventory levels have changed in 2022 because the Kronos demo is 2023 in my demo for our top 10 items. So it's complex because you need to go, it needs to perform a set of queries to retrieve that. What are my top 10 items? Then I need to, for each top 10 items, I need to go into checking the item level. So it's something that quite complex for the LLM to perform. But here, what I want to show is that it's able, the service is able to also perform this, and it's giving me the output. So you can perform more. I can do other examples that I want to spend a lot of time. So here, the agent is able to do a lot of queries in my Business Central data, a set of queries, not one, a set of queries in order to give me the response. What's there under that? First of all, there's a Business Central app, this app. And here I don't want, so the most basic stuff is knowing all the questions that the user can do, and then provide the tool to the kernel. But I don't want to do that. Here I've done something a bit more complex. So in my IL application, DSK application, in the prompt dialog page, when the user types the request, the prompt dialog page creates a prompt that contains all the definitions of the APIs that I have available in my Business Central environment. So it goes into the page metadata, retrieves the page with type APIs, creates the data, retrieves the data from the APIs. For each APIs, retrieves the fields available in each APIs, and this is transformed into a YAML that I'm passing to as prompt to my kernel. So my kernel now knows the question, and now he knows that for answering the question, he has available all this set of APIs, custom and standard, with this type of fields. So he has all the tools. But now you need to use So how can an AI agent, okay, an AI agent now knows what are the available APIs, but how he can use the APIs correctly? This is handled in the prompt. So first part is my Business Central application. And my Business Central application simply calls my, not Azure OpenAI, but it calls, not here, but the prompt dialog page. Sorry, I don't remember. Okay. It calls my function. So it calls my semantic kernel function, that is this. So it calls my function where I've exposed my kernel, passing the prompt. So the prompt containing the API definition. In the function, and the function is this other project. In the function, I simply retrieve the request, and according to the request, I retrieve a prompt, and the trick here is the prompt. Retrieves the prompt, and then it uses the kernel to perform the request. And the request, there's this function, kernel function, that calls a Business Central API in a particular environment. It's the prompt that redirects the API calls. How the prompt is doing is done. The prompt is this prompt, something like that. So here it's a real-world application. So as said before, in a real-world application, the prompt should not be in the code. So here I have a prompt that is downloaded from Key Vault, for example. And the prompt for me is a complex text file, this text file. But the key part of this text file is that here I'm explaining to the model how an API should be used. So you have a set of APIs. According to this set of APIs, this is how you should format the URL. So the URL for standard APIs must be formatted in this way. For custom API, in this way. How you should apply filters. P-filters must be applied according to OData filter. So filter, and here I am providing all the filters they can apply. So all the rules, I'm explaining the model how to call the APIs. And then I add the extra guidelines for example, for ending dates, if you have an error, do that, and something like that. So with all this set of instructions, with the list of my APIs, and also the metadata of my APIs is able to perform the query. So this you can have a quite nice performant way of handling complex data, much more powerful than, for example, the standard Copilot chat that you have inside Business Central standard. Last part of semantic kernel is this, because I think that you have listened these terms today. So Model Context Protocol. Model Context Protocol is an open protocol created by Anthropic, and that now is becoming a standard. And the great thing of Model Context Protocol is that you can support this scenario. So instead of having instead of having an LLM that for each question goes into different data sources according to each data source has its own capabilities, its own APIs, and so on. Now it simply interacts with an entity in a standard way, and then this server is able to have the interface for the particular data source. So this is how the MCP protocol works. So the host can be different. Can be Business Central, because Business Central will support MCP. It's a work in progress. Can have Claude, like we showed it this morning in the keynote. Can be GitHub Copilot. For me, should be the first choice at the moment. GitHub Copilot can support MCP from not recently. And GitHub Copilot can call, for example, every MCP server you expose. And can be a different. Also, Copilot Studio, if you want, can support MCP. So every client that supports that, you simply register this into the client, and then it's able to call each target system by using that protocol. And this is absolutely important because you can, if you create this can be used by Business Central, can be used by one of these tools, can be used by Copilot Studio, and this is why Microsoft has started adopting this technique and will change in the future all, or at least many of the connectors available today. Semantic Kernel supports two types of protocols. No, Semantic Kernel, sorry, MCP supports two types of protocol for connecting with the target system. The first is what is called standard input-output streams. So it is useful for running locally agents. I have an MCP server running locally, then I use this protocol. If I have an MCP server running online, I use the other protocol, HTTP via SSA, server-side events. Using that, Semantic Kernel supports MCP. So if you have an agent created in Semantic Kernel, like we show in the demo, it can support MCP with a few lines of code. First is declaring this. You need to add the package, MCP client factory package, and then you create your MCP server. When someone gives you an MCP server needs to provide you the URL and the protocol that it supports. And then you can use, an MCP server can have tools, so a set of functions available. You can use, with this line, list all the tools that this server has available and then use from your model. Just to show you a very quick demo on that, this demo. Let me close this. Here, for example, I have created a very simple agent that uses the MCP server provided by Playwright. Playwright is a nice tool that is able to run applications by going into opening the application, simulating the user interaction. So here, in my application, I've declared the MCP server from Playwright. So using this is running locally, so I use this method. The name is Playwright. The command to run is this. That is a command to run the MCP server from Playwright. And then from my agent, I simply asking, summarize the latest articles from this site, my site, and open the first link and summarize its content. So I want that this agent is able to open this site, check the latest article on this site, summarize that for me, and give him the response. If I run this, you should see that if Playwright is working, this is the website is opened. Automatically, the latest article was open, and then the AI model is reading my latest article, closing the website, and here is the summary. So, latest article, the title, using a static API address from API, discusses a solution, blah, 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 blah. So this is a summarization of my item. This is useful also, for example, for simulating testing the Business Central user interface. So an MCP server can open Business Central, can simulate clicking something in the user interface and doing task. So just to show that an agent can also call an MCP server. An MCP server can be the Microsoft provided MCP server, so working with Business Central data easily, doing nothing, as we show in the keynote today, or your custom MCP server, or your third-party provided MCP server. So simply declaring the MCP server, the key line of the code is this. Not this, sorry, this. So you declare the server, and then when you have declared the server, you need to say, okay, now give me all the tools that you have. And he is downloading the list of tools that the MCP server is exposing, and then he can perform the actions. So it's absolutely powerful for making complex tasks. This will be probably the future, because the idea in the future is that all the connectors will be probably moved, or at least not all, but quite all. The connector related to Business Central agents will be moved to MCP. So just to close, Semantic Kernel, why in Business Central solution? Because it's powerful. Because it permits you to create no limit solution. So it can overcome all the limits that you have in Copilot Studio, that you have in the IL SDK. You can work with different AI providers. You can customize the workflows in multiple agents as you want, and it's scalable. It can scale according to your needs. Something that Copilot Studio cannot do, something that IL SDK cannot do, because it cannot scale as you want. And also it's platform independent. And this is something that in many real-world AI scenarios is useful. So pros and cons. Lots of pros. Cons is that it's full code. So it requires a pro developer. But as explained also in the keynote, this is the third part of the agentic AI possibility that you can have. So it's totally up to you to select if you want to go for the low-code solution, Copilot Studio, with all the limits, with all the costs, or full-code solutions, no cost, but except obviously the interaction with the model, but no Copilot messages, no, simply you pay for the tokens and nothing more. So this ends this presentation. I hope that you have at least the building blocks for starting exploring this framework. I suggest to start, because if you want to create complex AI solution, it's great. If you have questions, lots of questions. Should be a microphone here. Let's start with microphone. Maybe works that. I don't know if. I
don't know.
No, let's start.
My question would be: is it completely separate from standard Copilot chat? Like user would have to navigate to our implementation-specific pages and could not call functions from chatting with general chat.
The chat, you mean the chat in Business Central?
Yes.
No, it's totally separate. So the chat in Business Central uses this tool under the hood. Obviously, you cannot, Microsoft has not yet opened the Business Central chat to the general public to customize. So you cannot change the general part. So this is something totally separate from the chat. It's a tool that you can use if you want to create your own AI solutions, maybe more complex AI solutions inside Business Central. You can use this tool, but it's absolutely separated from the standard AI chat.
Okay, thank you.
I have, sorry, 1 second. I have probably also some t-shirt if you want. One. Sorry. Second, I don't know the order.
Hello. Yeah, thank you.
Okay.
My question is also about multi-session. Is it possible to share maybe the history or something like that with the team or with the organization, so that we can earn profit from that?
If you can handle multiple sessions, yes, absolutely, yes. It's absolutely possible. You can handle multiple sessions with the agent. It's something that usually is done in a real-world application. using a full code solution, you have no limits on that. So it's totally up to you, deciding what is the limit of the session. Usually, at least in my case, I deploy this agent in running, for example, in Azure Function. It's totally up to you to scale the number, the service according to the number of sessions, or limit the rate limit that you want to have. Multiple number of sessions is absolutely supported by design. So no limits on that. Sorry, I go into this order because I see the. I give it to you, Mike. Yes, sorry.
Yeah, hi.
I don't see you.
Great. But
no, probably is better.
Yeah, if we have too many sessions that we want to have in a history, are we then reaching the maximum token limit, or that?
Obviously, the token limit is something that you need to handle. If you need, if you have multiple sessions, so in a real-world application, I usually suggest to scale the model. So scale the model means you cannot have one single deployment of, for example, GPT-4.1 serving 1,000 users working concurrently. You should, in these scenarios, if you reach, token limit is 4 sessions first. But obviously, if you have, imagine that you have 100 users talking with one instance of GPT-4.1, you probably reach your subscription limit or something like that. So in these complex scenarios, when you have multiple, you should deploy different instances of the models, and then routing the request. It's very easy routing the request. So you can deploy, I don't know, you have 100 users, you can deploy 5 instances of imagine GPT-4.1, and then redirect 20 users, goes to this, 20 goes to this. Automatically, it can be handled by the platform. Or you can wrap, for example, in, I don't know, Azure API management or something like that. You can run. This is exactly what Microsoft is doing under the hood when you call standard the standard Azure AI chat or the future managed service that will be released in a few months. Microsoft is not deploying one instance of GPT for every customer in the world, but is deploying multiple, and requests are routed accordingly to the load. So you can do that. Totally up to you.
Yeah, great. And then also for one session with some huge chat history.
For session, you have a limit. For a single session, you can have a limit on prompt. Limit on prompts is per interaction, so you cannot pass an extremely long prompt for a single interaction. And the limit of prompt in chat is not limited by the model, but is limited by your subscription. So you can, if you don't overcome the limit for request, you can talk with the model for hours without problems. So you have 2 levels of limits.
Great, thanks.
Oh, I don't know. Also the microphone.
Hello, I just have a quick question. You showed like 3 examples of doing kind of the same thing when it comes to plugins or the things you can do, or tell the AI to do, like the tools. First, I understood that you kind of gave him instructions through the same prompt and just gave basically a single tool just to retrieve from the API. But then you can also have that through logic apps, for example.
Yeah.
You just get that, and then the more advanced, and hopefully we get, is the MCP who already has that already defined for you. Let's get a standard way. Does that always affect the prompt size at the beginning? For example, in the first example, you have this large part of the prompt. Yeah. You have all that description in it. That affects, the initial, let's just say, the tokens you're going to use on that request. Is that true for the other 2?
No, the tools don't affect the size of the problem or the prompt. So the prompt is your specification of instruction that you give to the model. then the model can be enriched, and this affects the size of the prompt.
Okay.
Then you enrich the other with tools. Tools can be don't have nothing to do with the prompt. So tools are a set of tools that can be used by the model to answer a particular task or solve a particular task. These tools can be functions that you define in code or workflows that you have exposed to the agent, like in the example that I've done with the logic apps, or MCP servers. These are the free macro types of functions that you can define, but these don't affect the prompt size. So you can, your agent can have 100 of tools available.
And it doesn't really affect performance in the execution of the prompt if it has 100 tools.
No, they don't affect the limitation on prompts, because you don't pass that in prompts. So you attach that in the tool part of the model. It's not in the user prompt. Your limit is in the user prompt.
So does it affect performance in any way? Having
performance is another topic. Performance, performance can be impacted, because if an agent has, I don't know, 10 tools, or the same agent has 100 tools, when you have a request, the first need to check if these 10 tools is able to satisfy that. The other need to check between 100, and the agent, to detect the tools, use reasoning. What is the tools? I check the description, I check the parameters, I check the user question. So yes, this can affect performances.
Okay. Thank you.
I have two questions. First one is, do you know some tools that can simplify the cost calculation when you present this to potential customers that you want to use it?
Cost calculation, first of all, there are custom tools. I have, for example, a custom tool that does that. Probably I can share that. But the standard way to do, for example, using Azure OpenAI, is monitoring. When you call Azure OpenAI, it automatically has telemetry attached. So Azure OpenAI has a set of monitoring features for detecting the cost of calls and so on. So I suggest to enable it. But if I remember, maybe later if you can go here, if I remember, I have shared in the past, probably on my GitHub, there's a template that you can simply install into your Azure subscription. Cost is 0. Or your customer subscription. And these templates, when you have an AI model deployed, gives you all the requests that has arrived to that. These requests can be grouped by IP address, by tenant ID, and something like that. So you can know this customer has consumed X, this other has consumed Y, and so on. If you provide a custom AI solution, you should handle that. So otherwise, you don't know how a customer is spending.
Okay, and my second question is this possible to be run fully offline?
Yes, absolutely yes. I don't have the time to do that because time is running, but I have some demos ready that, no, time is up, sorry. But Semantic Kernel supports, for example, running AI services in Ollama. Ollama is a service that permits you to run a local model fully local. It also supports a service launched called Foundry Local. Foundry Local is a service recently launched build that permits you to deploy open source model offline. And this is absolutely, in my opinion, a great way to start with AI in many customer scenarios, because cost is 0. Simply deploy a model, and there are lots of open source models that can satisfy every business central related, AI related task that you want. that you can fully run offline. So the answer is yes, it's totally supported. Instead of using add Azure OpenAI chat completion, you can use add or Llama chat completion, for example, and then you can have a model running offline or model running offline answers to a local service, local host, something. And then your code is simply one line of modification and then runs offline. So it's a great scenario.
Thanks.
Microphone maybe.
I think this. Yeah.
Thank you.
Hi. I want to ask if orchestration is not working as you expected. How can you test it and fix? Some scenarios, perhaps the agents don't do what is.
If the orchestration, well, you have, first of all, you have logging. You can enable logging. Enable logging is a one line of code, builder.service.enable logging. And this adds to application insights all the traces that your agent is doing. This is probably the first level of debugging that you can do. Second, you can test the agents. But orchestration means multiple agents working together. And this is something that obviously you should test. Orchestration often depends from the prompt. So if the prompt is well done, the agent is able.
Don't test every possible prompt.
Exactly. You should have a good prompt in order to be able to, the main agent, to redirect requests to the others, especially in multi-collaboration. So the orchestration is easy when you have, for example, the sequential pattern. So agent 1, agent 2, agent 3. This is very easy. Nothing to do.
It's hands-off. Imagine
it's exactly. When you have this type of pattern, so where someone received the request, and then I can route this request to him, according to the needs, and then I can receive, then I can route again. This is the real complex. So this, if the prompt is good, the orchestration is good. If the prompt is not good, sometimes the orchestration can fail.
How can you ensure that the prompt is good?
Testing. Testing means you should test your application. You should log. You can log what happens when I receive this prompt. What are the agents that are routed, interacted. Usually I use logging and testing. You have no other tools to test if the multi-agent orchestration works good. Honestly,
okay.
You should log and perform prompt tuning. This is why I said that don't keep prompt in code. I prefer in a real-world solution to have the prompt outside, because you can change, simply change the prompt, rerun again, and see what happens. You can also turn up the prompt during the months, exactly like Microsoft is doing. Microsoft is never, in all the Microsoft provided AI solution in BC, never stores the prompt inside the code. Prompt is always stored in Key Vault, and the Copilot chat, all the other Microsoft features downloads the system prompt from Key Vault, never in code, because Microsoft is changing the prompt, can change the prompt every day according to logging so you should do something like that. So no other tools, honestly, for that.